Dear students, so in this class let us discuss about our third module, that is based about the sets, metric, open spheres and so on. So first you consider a non-empty set X will be a non-empty set, and we define a function d from x cross x to R, where x is a subset of R. Define d from x cross x to R. Then this d is said to be a metric on R. D is said to be a metric on R if d satisfies some of the properties. First one, dxy greater than or equal to 0. What is actually dxy? Means it is the distance between x and y. Dxy is nothing but the distance between x and y. So dxy, first property is dxy greater than or equal to 0. And the equality holds. Dxy equals 0, that means x coincide with y, x equals to y. Also, it is symmetric, means dxy is same as dyx. And d has the triangle inequality, means dxy less than or equals dxz plus dz. So if any function d satisfies these properties, that d is said to be metric on R. Agree? So a space together with a non-empty space x together with a specified metric is said to be a metric space and is denoted by xd. X is a space, x is a vector space, d is a specified metric. So the vector space together with a specified metric d, which is denoted as xd and is known as the metric space. Okay. Now consider the trivial metric. We may define a trivial metric. Let x be a non-empty set, and d is defined as dxy equals 0. Dxy equals 0. Dxy equals 0 when x equals y. Dxy equals 0 when x equals y. And 1 if x differs from y. If you define the metric d on a non-empty set x in such a way that dxy equals 0 if x equals y, 1 if x differs from y, then this d is said to be the trivial metric. Is said to be the trivial metric. Is said to be the trivial metric on x. Okay. Now, if you define another metric dxy equals, suppose d is a function from x cross x to R by dxy equals modulus of x minus 1. Do you say that d is a metric here? Sure. Why? Dxy equals modulus of x minus y. Then to show this d is a metric, we have to show that d satisfies three properties. First one, what is dxy? Dxy equals modulus of x minus y. It is greater than or equal to 0. Immediately. Why? Because there is modulus. Okay. Then here equals 0, that means when x equals y. When x equals y, modulus of x minus y is 0, so equality holds there. Now we have dxy equals modulus of x minus y. Modulus of x minus y is same as modulus of y minus x. Y mod a minus b is same as mod b minus a. So clearly it is a dyx, that means symmetry is also satisfied. Okay. Moreover, what about the triangle inequality? We have dxy equals modulus of x minus y. This is same as modulus of x minus h plus h minus y. We can introduce minus h and plus h simultaneously. So by the property of modulus, it is modulus of x minus h plus modulus of z minus y. Modulus of x minus h is dxh. and the modulus of z minus y is dz. So this is the triangle inequality. That is dxy less than or equals dxz plus dzy. So clearly dxy, that is modulus of x minus y, is nothing but a metric. Okay. So this is the best way to prove that the given function is a metric or not. Clear? Okay. Now, suppose D is set 1, set 2. If instead of R, you can define D from x cross x to C. What happens here? D from x cross x to C, where C be the complex field. Instead of R, here it is C. It is defined as with a D of Z1, Z2, where Z1 and Z2 are any two complex numbers, such that D of Z1, Z2 is modulus of Z1 minus Z2. So, in the same argument, in the light of this argument, we can immediately conclude that D Z1, Z2 is also a metric. Sure, same arguments. Instead of x and y are real numbers, here Z1 and Z2 are complex numbers only. Agreed? So, we know that modulus of Z1 minus Z2 greater than or equals 0. Equality holds only when Z1 equals Z2, and so on. So instead of R, here it is C. Then if we define the function D from x cross x to C, such as D of Z1, Z2 is mod Z1 minus Z2, then it is also a metric. Clear? By the same arguments. Agree? Okay. Now, let x be a metric. Let x be a metric together with a metric space. X be a metric space together with a metric D, means let x D be a metric space. Then define d1xy equals dxy by 1 plus dxy. Dxy by 1 plus dxy. Show that this d1 is a metric. It is given d is a metric. D is a metric means D satisfies the conditions dxy greater than or equals 0, dxy equals dy by x, and dxy less than or equals dxz plus dz. Triangle inequality. So since D is a metric, D satisfies all of these properties. And D1 is defined in terms of dxy. D1 is dxy by 1 plus dxy. Then our aim is to show this D1 is a metric. So in order to prove this D1 is a metric, we have to show that D1 satisfies these three properties. Okay. So since D is a metric, dxy greater than or equals 0. Okay. Why? Because D is a metric. Since dxy greater than or equals 0, this numerator greater than or equals 0, 1 plus dxy also greater than or equals 0. Okay, when dxy greater than or equals 0, 1 plus dxy also greater than or equals 0. Numerator and denominator greater than or equals 0. So this should implies d1xy greater than or equals 0. Clear? Okay. Now, so now dxy equals 0 when if and only if x equals y. If and only if x equals y. Why? Because again D is a metric. Okay. Now d1xy equals 0. Let d1xy equals 0. d1xy equals 0 means what is d1xy? dxy by 1 plus dxy equals 0. So this fraction equals 0, that means its numerator equals 0, means dxy equals 0. dxy equals 0, that if and only if x equals 0. So clearly d1xy equals 0 if and only if x equals y. Hence the second problem. So the equality is also held. Okay? Right. Now come to the triangle inequality. Sorry. Symmetry. How to cross the symmetry here? What is d1xy? d1xy is dxy by 1 plus, again for the symmetry, d1xy equals dxy by 1 plus dxy. But dxy is same as dyxy because d is symmetric. That's already given. Okay. Divided by 1 plus dyx. You can replace dxy by dyx. Why? Because d is symmetric. What is dyx by 1 plus dyx? So it is d1x. Okay? By definition. Thus d1xy equals d1yx. Symmetry is also satisfied. Come to the third property, that is triangle inequality. How to prove the triangle inequality here? What about d1xy? It is given d1xy equals dxy by 1 plus dxy. Okay. Can be rearranged as it is 1 minus of 1 by 1 plus dxy. Okay. Taking LCM, what do you get? 1 plus dxy minus 1. 1 and minus 1 cancelling each other. What means? dxy by 1 plus dxy. So dxy by 1 plus dxy can be rearranged as 1 minus 1 by 1 plus dxy. Okay, right. That means which equals 1 minus 1 by what is dxy? Dxy is symmetric. Dxy is it is given dxy is symmetric. Hence dxy satisfies the triangle inequality. dxz plus dz. Okay. So which is less than or equals 1 minus 1 plus dxz plus dz. Why? Because dxy is a metric. Okay. Taking LCM, what is 1 plus dxz plus dz by minus 1 by this denominator. Okay. 1 and 1 cancelling each other. So finally it is dxz plus dzy by 1 plus dxz plus dz. Okay. After taking, let's see, which is same as term by term division, that is dxz by 1 plus dxz plus dzy means dxz by this denominator plus dzy by this denominator. Okay, term by term split equals. So which is again less than or equals dxz by 1 plus, what is the denominator? 1 plus dxz plus dzy. Both are positive quantities. dxz is a positive, greater than or equals 0. dzy is also greater than or equals 0. Why? Because d is symmetric. Okay. So therefore dxz by 1 plus dxz plus dzy is less than or equals dxz by 1 plus dxz plus dzy by 1 plus dxz plus dzy, which is less than or equals 1 plus dzy. Okay. Why? Because dxz is positive, dzy is also positive. So this inequality is strictly called. What about this one? That is d1xh. What about this one? That is d1zy. So clearly, finally, d1xy less than or equals d1xz plus d1zy. Thus the triangle inequality also finished. Hence, d1 is nothing but a metric on x. Clear? That is what we previously. Now, if X is a non-empty set, consider another such. Let X be a non-empty set. D be a real function of ordered pairs. D be a real function of ordered pairs of elements of X which satisfies the following two properties. Here D satisfies, D be a real function of ordered pairs of X which satisfies only two properties. The properties are, first one, dxy equals 0 if X equals 1. Second one, dxy less than or equals dxz plus dyz. The triangle inequality is holding, and the equal property dxy equals 0 if and only if x equals y is also holding. Then show that D is symmetric. So to show D is symmetric, only when D satisfies the properties dxy greater than or equals 0 and dxy equals dyx, that is the remaining two properties in order to show this D is a metric. Here only D satisfies two of these properties. So in order to prove D is a metric, we have to show that D satisfies the remaining properties, that is dxy greater than or equals 0. Moreover, dxy equals dyx. Okay, how to prove this one? So, it is given, this is the first one, dxy equals 0 if x equals y, and dxy less than or equals dxz plus dxz plus dyz. Dyz means dzy, whatever may be. Then, first we replace first we show dxy greater than or equals 0. dxy greater than or equals 0. How to prove this dxy greater than or equals 0? So for replace x and y by x and z by y into. You may replace, consider the equation 2, triangle inequality, or dxy less than equals dxz plus dyz. First we replace x and y by x, because x and y fall in where? Here x and x, y is said to fall in x itself. So for any x fall in x, you can replace this x y by x and z by y. What equation? 2 becomes dxx less than or equals dxy plus dy. Okay? Replace x and y by x and z by y in equation 2. So you have dxx less than or equals dxy plus dy. What is dxy? Dxx 0. Why? Because when x equals y, dxy equals 0. Means dxx equals 0. So 0 less than or equals dxy plus 0. Dy also 0. 0 less than or equals dxy means dxy greater than or equals 0. So first part is finished. Okay, right. Now for the what remains to show the symmetry. What is symmetry? To show symmetry, it is enough to show that dxy equals dyx. dxy equals dyx. How to show this one? So for put put z equals x into z equals x in equation 2. Z equals x. What do you get? 2 becomes dxy less than or equal z equals x. So it is dxx plus dyx. Dxx plus dyx. What is dxx? Dxx is 0. So that means dxy less than or equals dyx. Mark it as equation 3. Dxy less than or equals dyx. But our aim is dxy equals dyx. How? Again, interchange x and y in equation 2. Interchange x and y in equation 2. So what do you get? That is dyx less than or equals x and y. So it is dyx less than or equals dyz plus dxz. Interchange x and y in equation 2. So it is dyx less than or equals dyz plus dxz. So here replace z by y. What do you get in equation 4? By y in equation 4, comma we have z by y dyx less than or equals, it is dyy plus dxy. What is dyy? That goes to 0. So what it means? That means dyx less than or equals dxy. Mark it as 5. Combines 3 and 5. What is 3? dxy less than or equals dyx. And 5 is dyx less than or equals dxy. So if you combine, you have dxy equals dx. Equality holds. Okay.